In this homework video guide, we will be looking at some of the average value problems. And for the very first question, we need to find the average value for the following functions on the given interval. So in this very first problem, my given interval is 0, 3. And then we also need to find all values of x where the function attains its average value. Okay, so in class we talked about the formula for average value, which is this formula right here. So throughout this homework video guide, we'll be putting in the numbers and the functions into that formula. Okay, so if I go ahead and calculate the average value, I'm going to write out y average one more time. And this will be 1 over b minus a. Well, b is my upper bound, so my upper bound here is going to be 3, and my lower bound is going to be a. So if I do b minus a, I get 3 minus 0. And then I go from the integral from 0 to 3. And my function here is going to be the quadratic, which is 9 minus x squared. So I'll put a bracket here and put in 9 minus x squared. And I'm integrating this with respect to x, so I need a dx there. Okay, so there is how we input the upper and lower bounds and the function correctly into the average value formula. And now we just need to calculate this. So 1 divided by 3 minus 0 is going to be 1 over 3. And then for this part right here, we need to apply the fundamental theorem of calculus. So this part that's shaded in yellow here, let's go ahead and apply the fundamental theorem of calculus here. So the antiderivative of 9 is going to be 9x minus, and then the antiderivative of x squared is going to be x to the power 3 divided by 3. Then close the bracket off. And then my lower bound is going to be a 0, and my upper bound is going to be a 3. Okay, so if we go ahead and apply the fundamental theorem of calculus again, we need to start with our upper bound, which is 3. So 3 gets evaluated first. So if we do that, we get 1 over 3, open bracket, and this will be 9 times 3 minus 3 to the power 3 divided by 3. And then the fundamental theorem of calculus states that I need to subtract. So this is really your f of b minus your f of a, and I'll put a bracket here. And if I want to calculate f of a, I take my lower bound, and my lower bound now gets inserted for all the x values. So this looks like 9 times 0 minus 0 to the power 3 divided by 3. And I can close that bracket off. That's f of a. And then I can close off the bigger bracket right like that. Okay, so that's the fundamental theorem of calculus right there. And what we need to do now is we need to evaluate this. So it looks like this part here just goes to 0. Okay, so we can just evaluate the front part of this problem. So this will be 1/3, open bracket, 9 times 3 is going to be 27, minus, and then 3 to the power 3 is 27, and 27 divided by 3 is going to be 9. Okay, so now we have 1/3 times 27 minus 9 is going to be 18. And 18 divided by 3 is going to be 6. So our average value here is going to be 6. Okay, now let's go back to the original problem here. That's part 1. So the average value is going to be 6. And let me just kind of erase all this. Okay, so basically when we found that their average value is 6, here's the value of 6. Part B is asking, sorry, the second part of the question is we need to find the values where we obtain the average value. So the question might be, what is this x value right there? Okay, so the average y height is roughly 6 in this domain from 0 to 3. So obviously some heights are going to be higher than 6 as indicated by this red line, but some heights are also going to be lower than 6 indicated by that red line. But the average of all the y heights is going to be roughly 6 in that given interval from 0 to 3. Okay, let's go find the x value where the function attains its average value. So all we need to do now is we know that the function is y equals to 9 minus x squared. And we know the average value has a value of 6. And now we need to find the x values that have a height of 6. So a little bit of algebra here, bring the x squared over, then bring the 6 over, and then x squared would equal to 9 minus 6, which is 3. And then if we square root both sides, it looks like the x value would be plus or minus root 3. But since we're in the domain between 0 and 3, the answer would be x equals to root 3. Okay, so this is the x value where the function attains its average value. So going back to my diagram here, this x value is root 3. Okay, so there we go. That answers question number 1. So question number 1, the average value is going to be 6. And the x value where the function attains its average value is going to be root 3. All right, so there's your answers for question number 1. Okay, so move on to the next question here. Question number 3 here. So this time I have a semicircle as indicated by the square root of 16 minus x squared. And I'm in my domain between -4 and 4. All right, so there's my semicircle. So if I want to find my average value here, once again, this is going to be 1 over b minus a times the integral from a to b of f of x dx. Okay, so it looks like my upper bound is going to be 4 and my lower bound is going to be -4. So if I go ahead and input that into my formula now, I get 1 over 4, and then minus a negative number is going to be plus, so 4 plus 4. And then I have the integral from -4 to 4, and my function here is the square root of 16 minus x squared, and I'm integrating this with respect to x, so I need the dx there. Okay, let's go ahead and start calculating this. So the coefficient will be easy. It's 1 over 8. And then this part right here, 16 minus x squared in the square root, that's really, you know, we don't need to apply some sophisticated algebra here because we know that this is a semicircle. And we know that the area of a semicircle is the area of a circle divided by 2. So the area of a circle is really pi r squared. And then what we're going to do with our semicircle, with our circle here, is we're going to divide it by 2 because it is a semicircle, right? So we recognize that the area underneath this graph is just the area of a circle divided by 2. And we know that the radius here is just 4. Okay, so if we continue with the calculations here, I would get 1 over 8. Open up the brackets, pi, and my radius here is going to be 4, so 4 squared divided by 2, and then I close the bracket. Okay, and let's see if we can just do further calculations here. So this is 1 over 8, square bracket. I have my pi here, and this part right here, 4 squared, is going to be 16 divided by 2, and then I close the bracket. Okay, and then we can see here that 16 divided by 8 is going to be 8. And then, no, sorry, 16 divided by 8 is going to be 2, and then that 2 can cancel off with that 2, so now we're just left with pi. So the answer here is just pi. Okay, so the average value of this function is pi. Okay, the next part now is, if I go ahead and just erase this, we need to find where the function obtains its average value. So I erase all this now. So we know the average value was pi, and we want to find the x values where the function has this value. So our function was square root of 16 minus x squared, and we just made that equal to pi. So I believe pi is around here. This is pi. And if I go to my semicircle, I guess there are 2 x values. Here's x1, and here's x2. There's 2 x values that have the average value of pi. And we just need to solve for this equation here. Okay, so if I square both sides, I get pi squared equals to 16 minus x squared. If I bring the x squared over, I get x squared equals to 16 minus pi squared. And then I take the square root of both sides. So my final answer is x equals to plus or minus the square root of 16 minus pi squared. Okay, so those are the x values where I obtain the average value. So one of the x values is positive over here, and then the negative value would be that one over there. Okay, good. Let's move on to the next average value question here. Okay, so for question number 5, I have this exponential function of y equals to e to the x minus 1. Okay, so if I want to find the average value, so I'll write down y average. And instead of writing out the entire formula, let's just go ahead and start plugging the numbers into the formula. So my upper bound is ln 3, so 1 over ln 3 minus my lower bound, which is 0. All right, times the integral of my lower bound, which is 0, and then my upper bound is ln 3. And then my function is e to the x minus 1, and this is being integrated with respect to x, so I need a dx there. Okay, so there's my y average formula right there where I've inserted the right numbers. And let's just go ahead and start simplifying this. So this will be 1 over, and if I have ln 3 minus 0, I just have a ln 3 on the denominator here. And then using the fundamental theorem of calculus, let's find the antiderivative of e to the x minus 1. And the antiderivative of e to the x minus 1 is e to the x minus x. Close that bracket off. And then my lower bound is 0, and my upper bound is ln 3. Okay, so now we need to apply the fundamental theorem of calculus here. So the fundamental theorem of calculus states that your upper bound gets inserted first. All right, so this will be 1 over ln 3, and this will be e to the power of ln 3 minus ln 3, and then the fundamental theorem of calculus states the fundamental theorem of calculus states that you need to subtract. So this is your upper bound f of b minus f of a, and in order to capture f of a, I will put another open bracket here, and then we'll start inserting our lower bounds. So this will be e to the 0 minus 0, so that's f of a, and then I'll close the bracket off like that. Okay, so there is my fundamental theorem of calculus being applied to this problem here. All right, so one of the problems with the fundamental theorem of calculus is it creates a lot of work to do. So hopefully we can just work on our simplifying skills here. So 1 over ln 3. And this part right here, e to the power of ln 3, if you want to simplify that, that's simply just going to be positive 3. Minus ln 3, and then if we distribute this negative sign here, we get minus, well, e to the 0 is really just 1, and then I guess I have a plus 0, which doesn't really do anything, but that's what I have in the brackets there. And if we go ahead and simplify this, I guess I have a 3 minus 1, so 3 minus 1 is going to be 2, so 2 minus ln 3. And then we still have this 1 over ln 3, so I can divide this whole thing by ln 3. Okay, and then if we further simplify this, I guess we can break this up into two fractions. 2 divided by ln 3 minus ln 3 divided by ln 3. So we're creating two fractions there. And this part right here, ln 3 divided by ln 3 is just 1. So my final answer is 2 over ln 3 minus 1. So there is my average value there. Okay, let's just go back to the start of the problem here. So that's the average value, and then the next part of this question is that we need to find the x values where the function obtains its average value. So we have a little bit more algebra work to do here. So let me just create some space here. So my original function was y equals to e to the x minus 1, and we want to find the x values where the function has its average value. So that means we just set our y to the average value that we found, which is 2 divided by ln 3 minus 1 equals to e to the x minus 1. Okay, so now we just solve this equation here for x. I noticed that this negative 1 and that negative 1, that will cancel off, giving you 2 over ln 3 equals to just e to the x. Whoops. Equals to e to the x. And then what we do now is we just ln both sides, so ln that, and then ln that. And then you'll notice that this ln and this e, that kind of cancels off, giving you just the x. And on the left hand side, I have ln bracket just 2 divided by ln 3. Okay, so that should do it, though. That is the x value where the function obtains its average value. Okay, let's keep on moving along. I guess next one here, we have a trig function here, so these are always great. So I need to find the average value here. And just like the previous problem, let's just jump right into the formula here. So my upper bound is pi, so pi minus my lower bound here is going to be 0, so pi minus 0 times the integral from 0 to pi. And my function here is going to be sine x, and then that's being integrated with respect to x, so I need a dx here. Okay, so let's go ahead and evaluate this one here. So this one's just a trig problem now. So 1 divided by pi minus 0. So the coefficient is going to be 1 divided by pi. And then square bracket here. The antiderivative of sine x is going to be negative cos x. and then I'm going from 0 to pi. Now, a good little trick here is if you have a negative coefficient like that, I would just park it to the outside. Okay, so move that minus sign to the outside like that, and just keep everything in the square brackets a positive. And this is much easier to evaluate because now you need to just deal with just cos x, right? So this will be negative 1 over pi. And then using the fundamental theorem of calculus, we use your upper bound first. So this will be cos of pi minus our lower bound, which is cos of 0. And I find that this is a little bit easier. I would find that this expression is a lot easier to figure out since we've factored out that negative sign from the get-go. And just think about the graph of cos x, right? So some students look at the unit circle. I just kind of look at the graph here. So cos of pi, here's pi right here. So this means cos of pi has a value of negative 1, and cos of 0 has a value of positive 1. So this will be negative 1 minus 1. All right, so cos of 0 has a value of 1, right? And then I had the negative 1 over pi in front. Okay, so if you evaluate this, inside the brackets I have a negative 2, and then I have the negative 1 over pi. So if I multiply that out, I get 2 over pi. Okay, great. The next part of the calculation, the next part of the problem is a little bit trickier because I need to find all the x values where this function obtains its average value here. So I know my average value here is, sorry if I just erase all this. Throughout this problem, we did a bunch of work and we did find out that our y average was, what was it again? It was 2 over pi. Just double check that. Yeah, 2 over pi. Okay, so maybe 2 over pi is maybe somewhere over here. And if I just draw a horizontal line here, I mean, there's an x value here and an x value there. All right, so let's just say this is 2 over pi. So there's two x values in the domain 0 to pi where this function obtains its average value. It's just that it's very hard to solve this particular equation here, 2 over pi equals to sine x. This is not like a simple trivial one where you have exact values. So you would actually have to go to a graphing calculator and graph this out and find the x-intercepts. So if I give you a visual right here, this is going to be pi over 2, the average value. And it turns out that our first x value is going to be 0.69, and our second x value is going to be 2.451. So those are the two x values where the function obtains its average value in the given domain, and we do need to go to a graphing calculator to figure out those answers there because you cannot get an exact value. Okay, let's keep on moving along. All right, so let's go over one of these trapezoid questions here. So in this question, they give you this table of values, and it tells you that you're given some rates here, and your goal is to use the trapezoid rule to approximate the average flow of oil during the first 18 minutes with 3 sub-intervals of equal length. Okay, so this is a bit of a tricky question because if you want to find the average flow rate, so if I use, if I just say flow rate, and we're trying to calculate its average, it's really this idea of 1 over b minus a times the integral from a to b, and you're just finding the area underneath the curve for your rate with respect to t. Okay, so throughout these homework problems, I mean, this part here is the same. It's just that this part right here, if I want to calculate that area underneath the curve, we're not going to use the antiderivative anymore, but instead, in order to calculate this integral here in that purple box, we need to use the trapezoid rule. Okay, so there's a lot going on in this particular problem to kind of figure out how to break this down. So let me kind of erase this now so I have a little bit more space. So I'll just say flow rate average is 1 over b minus a times the integral from a to b of RT dt. Okay, and what we're going to do now is we're going to set up the trapezoid rule to figure out this expression right here. Okay, so when you're given a trapezoid, let me just kind of draw a trapezoid out like this. In your notes, we talked about the area of this trapezoid, which is really h1, h2. This is your base. So if you want to find the area of a trapezoid, it's really going to be h1 plus h2 divided by 2 times the base. All right, so please check your notes out on how you can derive that formula. And since we have 3 equal subintervals in the first 18 minutes, I need to get 1, 2, 3. So this box right here, we're going to use that for our interval, right? So what that means is, basically for our h1 is going to have a value of 8. And our h2 value will have a value of 13, the endpoint there. So that's going to be 13. And if I look at my base now, the base of my trapezoid is going to be from 0 to 6. So since I'm going from 0 to 6 here, that has a base of 6 there. Okay, so if I had to figure this out, this would be 8 plus 13 divided by 2 times the base times 6. So that gives me the area of the very first trapezoid, and then I would go ahead and find the trapezoid for the next region here. So that would be this region right here, because we want 3 equal subintervals, 1, 2, 3. Okay, so once again, if I want to figure out what the area of this trapezoid is, we know that this is going to be your h1, which is 13, and this 12 will be your second height, and your base is once again going to be 6 to 12, which is going to be 6, right? So then I would have to just add plus, 13 plus 12 divided by 2 times the base of 6. Right, so that's like the general idea to get the area of the trapezoid there. So what I'm going to do now is I'm going to quickly summarize all this so that we can organize this in a nice way. Okay, so I'm going to erase all this now, and I will repeat this information again. So if I want to figure out the average value, let's figure out this 1 over b minus a first. So this will be 1 over, now I want the first 18 minutes, right? So your b value is going to be 18. So 18 minus, and your initial value is going to be 0, so 18 minus 0, times the integral from 0 to 18. And now I need to start writing out the areas of the trapezoid. And what we had before, so this r of t dt, this right here represents the area underneath the curve using the trapezoid rule. So if I just erase this now, I will put a bracket here. And let's see if we can figure out the areas now, the trapezoid. So our first trapezoid was 8 plus 13 divided by 2, and then times that by 6. So that's my first trapezoid. And that takes care of the first interval. We want 3 equal subintervals. So this is my first subinterval right there. And now what we're going to do next is we're going to add that to the next subinterval. So here's my next subinterval right there. And once again, we use 13 and 12 for the heights. So 13 plus 12 divided by 2. And the base is going to be 6 because these are all equal intervals. And finally, my last subinterval here is going to be this part right here, right? This will give me 3 equal subintervals. And now this time my height 1 is 12 and my last height is 8. So plus 12 plus 8 divided by 2. And my base here is going to be 6. One thing that you might recognize with the trapezoid rule here is if this is a 13, that has to be a 13, right? If this is a 12, that has to be a 12, right? That's how the trapezoid rule works. All right, let's go ahead and figure this out now. The coefficient is going to be 1 over, the leading coefficient is 1 over 18. And then bracket here. And then if I calculate this expression right here on a calculator, you should get about 63 plus, and then this expression right here, the middle term, 13 plus 12 divided by 2 times 6, you should get about 75. And then find the last term here, if you multiply that out, you should get 60. And yeah, a lot of calculations here, and I would just jump to a final calculator here to finish this, you should get 11, and the rate is going to be liters per minute. All right, so that was actually a very difficult question because we had to use the trapezoid rule, so a lot of calculation work to kind of get that problem done. Okay, let's move on to the last few questions here, and the last few questions, the instructions were to use a calculator because the first few questions of the homework assignment, they do take quite a bit of work to set it up. The good news is now we can use our calculator to finish off the last few questions here. So we need to find the average acceleration. So if I want to find the average acceleration, we can use our formula of 1 over b minus a, and our b value is 5 and my a is 1, so 5 minus 1 times the integral from 1 to 5. And since I'm looking for average acceleration, since I'm looking for average acceleration, I find my acceleration function right here, and we just plug that in here as 4t cubed minus 2t, close the bracket, and we're integrating with respect to t, so dt. And then from there, you can just jump to your final answer, and you should get 150. Okay, and that's it. One thing I'll show you right now is this is how you can input the function into Desmos. So here's your 1 over b minus a coefficient. There's your function there, upper, lower bounds, and there's your answer of 150. Okay, let's move on. Next question here. The velocity of a particle is this at time t, and I want to find the average velocity over this time interval. All right, so not a problem. So I want to find average velocity now, and that's the same thing as 1 over b minus a, and our b value is 3, our a value is 1, and then our lower bound is 1, or our upper bound is 3. And since I'm looking for average velocity, we just input the velocity function in here. So bracket 12t squared plus 1, close the bracket, and this is with respect to time, so dt. And then once again, you can go to your calculator that now, and you get 53 there. Okay, and this is how you would input the function into Desmos, and then you get an answer of 53 there. Okay, so these ones are much easier because the calculator can do all the heavy work here. Now for the second part of this question, we know that the velocity function was 12t squared plus 1. And if I want to find my acceleration function now, I just take the derivative, which is 24t. And this question wants us to find the average acceleration. So AVG, acceleration, equals to 1 over b minus a. So our b value is 3 again, or a value is 1. I integrate this from 1 to 3. And now I use my acceleration function, which is 24t. And I take the... I'm taking the antiderivative with respect to time here, and if we do this, we get 48 as a final answer there. Okay, and this isn't too bad to figure out, but actually, let's just do this. This will be 1 over 2, and the antiderivative right here, well, if this is a t, it gets raised to the power 2, so 24t to the power 2, divide by 2, and then we're going from 1 to 3. And if we quickly just do the calculations here, 24 divided by 2, I guess that's 12. So now I have 12t squared from 3 to 1. And all we do is plug in the 3. So this will be 12 bracket 3 squared minus 12 bracket 1 squared. And yeah, if we go to our calculator here, I guess this will be 1/2 times... that'll be 108 minus 12, and that gives you 48. All right, so a little bit of work there to get the final answer there, but these are all great questions just to review the fundamental thermodynamic calculus.